Hello everyone. Let's discuss about the first order circuit. This first order circuit step response. Okay, before starting to analyze the step response, I am saying that this RC circuit is a first order RC circuit. How I am telling is, if I can able to represent this whole circuit by using a single R equivalent and a C equivalent, then I can say that this is a first order RC circuit. To represent that one, if you have any voltage source or current source, replace voltage source with the short circuit and current source with the open circuit. If I redraw that one, it will look like this. My circuit, here is a resistor R1 and this is C1, this is C2 and this is R2. This is R1, this is R2, this is C1, this is C2. Okay, so this C1 and C2 are coming in parallel. That means C equivalent is equal to C1 in parallel with C2. From C equivalent terminals, if I see for the R equivalent, R1 and R2 are coming in parallel. So R equivalent is R1 in parallel with R2. Okay. So let's remember this R equivalent and C equivalent, which we need to use in the next further coming calculations. Okay, this is the input voltage which I am giving it to the circuit. This input circuit voltage is having 0 volt till t is equal to t seconds. Okay, this is 0 volt. At t is equal to t seconds itself, it is jumping from 0 to V volt and staying at V volt till t is equal to infinity. Okay, and I am taking a capacitor C1 and C2 which has the initial voltages VC1 and VC2 are 0 volt, so that VC1 till t is equal to t seconds are 0 and VC2 is also 0 volt. Okay, at t is equal to t seconds, as input is suddenly jumping from 0 volt to V volt, this input signal has infinity frequency components. Okay, so this input signal is being applied to the both capacitors because these two capacitors are connected in parallel. If I redraw this circuit, this will look like this: C1 and this is C2, this is C1, this is C2, this is V. So that at these high frequency signals are being applied to both C1 and C2, so that these capacitors for infinity frequency components acts as a short circuit, and both capacitors acts as a short circuit. And if I redraw equivalent circuit at infinity frequency, that means at t is equal to t seconds, this will look like this. Okay, one resistor R1 and resistor R2. This is R2, this is R1, and capacitor which is short circuited, this is C2, and there is one more capacitor which is also short circuited, C1, so that the current will flow from here C1, C2 and to the voltage source. No current will flow through the R1 and R2 because current will take the least resistance path. So if I calculate the total current which is flowing here, I is equal to V by R. Because R is equal to 0, current is infinite amount of current is flowing here. So that because here infinite amount of current is flowing, okay, the capacitor will quickly charge to VC1 and VC2 because of that infinite amount of current. So that VC1 is equal to V into C2 divided by C1 plus C2. So this voltage it will charge to this volt, okay, and VC2 will be V into C1 divided by C1 plus C2 volt. Okay, this suddenly at t is equal to t, it will go to VC1, and same way here this will also go to VC2. This will also go to VC2. Okay, at t is equal to infinity, because input supply is having only DC components, capacitors will act as a open circuit. If I redraw the equivalent circuit, this will look like this. This is a voltage source and capacitors will act as a open circuit. Still there is a R1 and R2, so that the current will flow through R1 voltage source, R1, R2. No current will flow through capacitors. So if I calculate the current I, here it will be V divided by R1 plus R2, and the current flowing through the R2 will be I into I, and voltage across R2 will be I into R2. here I into R2. Here same way voltage across R1 is I into R1, because the C1 is parallel to R1 and the C2 is in parallel to R2. So finally it will settle to these corresponding voltages. This is, let's assume this is VR1. Let's assume this is VR2. So at after phi tau, that means phi tau time constant, this Vc1 exponentially decay to, and this one exponentially rise to uh, VR1 and VR2 correspondingly. This time phi tau is a time constant, which is tau is equal to here R equivalent into C equivalent, which we already told here. Here tau is equal to R equivalent into C equivalent into phi, which is the phi tau constant. And one more thing which I wanted to say is the voltage, final voltages and initial voltage, whether this is exponentially charging or discharging, depends on the VC1, VC2, and also VR1 and VR2. So this VC1 and VC2 depends on values of C1 and C2, and VR1 and VR2 depends on R1 and R2. So if we change the C1 and C2 and R1 and R2, this exponentially decaying and rising might change.